G'day YouTube, this is Matt from OzTech Junkies. So as I was cleaning out the garage, I realised that I had something that I haven't really looked at or played with for since I got it. I kind of just got this and lumped it somewhere up there on the shelf. There's also another old vintage meter here that I will play around with later and possibly make a video, but as you can probably see from its condition, it's pretty worn out. But we've got this one today. So this is actually not one of those useless boxes you can buy at JCar, but this is actually a very useful box that was used probably in the early turn of the 20th century. It could be up to the 1950s. I'm not sure what kind of date is on there because I have not seen a date code. But what is it? Let's open her up. So this is a DC and AC voltmeter made by Elliott, I believe, and it says here for use horizontally. Now I'm not sure if they mean horizontally as it sits on the floor like that, or whether they mean horizontally like this, and it means that you can't, of course, stick it on its side. But let's have a better look now at this whole operation and kit caboodle. Over here we have a whole set of plugs to plug your leads into, with common 75 volt, 300 and 150. I'm not sure what this one is here, it's not marked. And on the other side we have this one here with a little bit of paper saying connect 300 and something to 300, and can't really read that. Bind to reading by 4. I'm going to guess that that's for your multiplication, because a meter is a 75 volt meter. So if you use different scales, you may have to multiply that scale to get your reading. The back is much more simple. You've got 4 rubber feet, and the bottom has the set 0 mark, which if we look at this right now, it's not quite there, it's 0. So I'm going to guess that if I was to stick my flat bladed screwdriver in there and adjust it, actually there we go, there we go, see how it's moving. So we're going to adjust that slowly down to 0 right there. You have to kind of get it centered enough to see that it's pretty close to 0. I'm not sure if this even works. It's got this nice timber lid on hinges that opens up, but we can surely go ahead and test this out to see if it works. So we're gonna stick this on this rag like so. I don't want to damage the box anymore, as it is pretty old. Up here we have my old laboratory power supply from the 80s. This thing will feed a series circuit of up to about 64 volts, so we can feed 64 volt DC into this meter, which will go up to 75 volt DC to just check whether or not it actually works. So let's do that. So now that we have this connected to our power supply, there are a couple of leads. And over here we've set this to serial mode, and we can now start to crank that up. So we have to remember that when we're reading these two power supplies, you have to add these two up. So if that's on around 5 volts, which is there, this might be reading, or should be reading about 10, and as we can see the needle has come up. So we're going to push that a little bit more to 20 volts, And have a look at this. This thing still seems to be accurate. So we'll keep on pushing it up. Now I'm going to wind down the current too so we don't get a big explosion. Just so a little bit of current goes through in case there is a short or something inside. I doubt there will be. And we can come up to 40 volts now. This thing's reading a little bit over 40. Now we'll go to 50 volts. And as we can see here, this has come up to 50. And last but not least, we can go to 60. And here we have a problem. So there is something stuck in the meter. I'll just ramp that down and see what happens. Yeah, it's not going past 50 volts for some reason. The needle is getting stuck there and it's not coming down straight away until I pull it down a fair bit. So right now I reckon we should take the front cover off. I'm pretty sure it comes off from the front, as I've been told by somebody who's been a bit technical with these old things. Don't take it apart from the back. So I'm going to take it apart from the front and see what on earth is going on inside. So let's do that. So we've taken it apart. We've taken the glass off and the timber front, and we're left with this. It does have a felt seal right along the front edge to try and keep some of the dust out, and I was very careful at taking this out because I didn't want to damage it or anything like that for putting it back together. But this is amazing. Have a look at the size of that massive coil at the back. So that's actually got two coils, one at the top. Let's see if I can get that in there. One at the top and the other one at the bottom. I'd guess that one is maybe for DC and the other one for AC, I'm not sure. When we were looking around at this side, I was wondering what that terminal post is for. Now, when I'm looking inside over here, it does not appear to be connected to anything. So, I'm not sure if this meter has been apart and, you know, somebody's taken that off there. So, if anyone has got this meter sitting around, if they still do, I'd love to know where that would have been connected, if it was connected, because I just find it unusual that that would be like that. But the rest of the cables up the back there seem and appear to be connected to the metering equipment, and I believe up the back, if we were to go up inside there, I believe in the back, in behind the actual meter face, I think there's some resistors in there, because when I look, it's a bit hard to get in there, but if I look in there, I might have to turn some light on in here. If I look in there, the wires are going in behind there, so I believe that there's some wire wound resistors in there, which I'm not able to test at the moment. But my main concern with this is that when I applied voltage, that the needle was getting stuck. So let's go and put that back on again and slowly ramp her up. So 75 volts is over here. Putting my alligator clips back on. There. And we'll ramp this back up. Negative in there. Oh, we're getting a bit stuck here, but it's alright. We'll turn this back on and slowly turn that up again. And as we can see, even now it's getting stuck at even less. But not too good. So I'm going to investigate this further and find out what's actually causing that to stick. It'll be something simple, but I have to spot it. So I have found the culprit of the issue that I'm having. I will show you. So if we move the needle slowly up the scale and it gets stuck, as you can see there, it's stuck. So what it is if we zoom into the zeroing mechanism down here, it is actually sticking on the zero mechanism. If we were to push this down behind it, it clears. So what I'm going to have to do is just slightly, ever so slightly and carefully bend this needle back. We can't cut it down because that acts as a counterbalance. And if we don't have that counterbalance, it's not going to operate properly. So I have to be careful here not to damage anything. I can't see the reason why it would be hitting that. Maybe it's been dropped in its lifetime or something like that. And so it doesn't function like it should. I'm not sure, but we will get it fixed. So I believe now we have it fixed. I've bent this little balancing rod back just a small fraction, just to clear this adjustment bracket over here. And what we want to do now is that I actually want to hook up a Fluke digital meter to these sets of leads here, and see how accurate this thing is after so many years. Mind you, this is using the 1-to-1 scale, so it should be as accurate as it can get on the 1-to-1 scale. If it's not accurate on the 1-to-1 scale, we'll probably have a problem with the coils in here. It looks like somebody has worked in here before, and I say that because I'll get some light on in here. So if we go and zoom into there, we can see that somebody has squashed the wire over here and soldered it back onto the coil at one stage in its lifetime. So I'm not sure how good this is going to be, but let's hook up the digital meter and see how accurate this thing's going to be after all these years. So we now have our digital meter hooked on to the circuit. I'll just get that somewhere where we can read it. I've got my my power supply up there turned on and ready to go. So we shall see how good this is. So let's ramp this up to, let's say, 20 volts. Or 20.2. That's as close as we can get it. As we can see now, this is not quite as accurate as we'd want it to be. Now, I know that there's a little bit of voltage loss in the thin wiring coming to here, but that should be pretty accurate. What I might do now is, because it says for use horizontally, I'm going to actually lay this down and see if that makes a difference with the accuracy of the meter. Now that it's laying down, we can see that it's popped up just a small amount, but still not quite where it should be. Let's just pop it up to 30 volts and see if it becomes more accurate. 29. So at 30 volts, it's actually Not too far off the mark. It's a little bit out, but not as bad as when it was at 20. Cop it up to 40 volts. And that's also slightly out as well. Now what we can do, however, is that we can probably use our screwdriver to, this might not be a zero check, we can actually tune this possibly. It has been a difficulty. I might have to do this off the camera for a minute. So to do this, we have to stick the screwdriver in the back end of it. It's a two-handed job, so. I think that's pretty close. So I've finally got it as close as I can get it at 40 volts. So let's keep on going up the scale to 50 volts. It's pretty much 50 volts, 49.9. It's reading a little over actually. So it definitely has lost a little bit of accuracy, but it's not bad. Can't complain for something that's this old, to be honest. We go to 60 volts. And there's 60 volts there. It is again a little bit over. Just having a hard time getting it right. I might actually adjust it at 45, right on the halfway scale actually, and give that a go instead. It's pretty hard to adjust this power supply over here to the 50 volts that you want it at. I'm just basically using a trim pot. That's bloody well close enough. Alright, so 45 volts. I'm going to adjust that right in the middle of the scale because that's right where it should be. And I think we're just going to take an average, you know, plus or minus 0.25 of a volt. Actually, it's fairly accurate when you look at this. It's, you know, 45 volts is coming at not even 0.1 of a volt inaccuracy. You know, that's basically next to nothing for inaccuracy. So, I mean, the flukes are usually pretty good. So, mate, am I happy with that? The only other thing that I'd like to test is whether or not the resistors are still working in the rest of this. So, let's go up again. We'll go to the maximum of what my power supply can do, 62.69 volts. And if we read there, it's on 61. Actually, we have to come across this side because the camera's off angle here. So, 62.5 volts. Look at that. That's within 0.1 of a volt accuracy, you know. So, I am absolutely pleased with that. So, let's just see if, you know, the 300 volt scales or any of the other scales will work. So the first one I'm going to try is the 150 volt scale. And it looks like a couple of the scales aren't used. That's why it's not marked. So we go to the 150 volt scale. The 150. It's coming up. 150, 75 to 150 is double. So if we double 31.1, comes to 62.2, very, very close. 300 volt scale, probably barely move at all. That's going to be very hard to read. So that's coming up as 10, 11, 12, about 15 volts, which looks about right. If you go and times that by the multiplication number, you'll be correct there. And of course we got no other scales. So now if I had a Variac, I'd be happy to put this on the 240 volt mains and a 10 milliamp RCD, but I don't have that equipment here. But I'd say that it's probably pretty safe. I mean, I wouldn't be using this above 100 volts with how old this equipment is. You know, I know that they did back in the day, but this isn't, you know, really built to our safety standards these days. But there you go. That's the cover for it. I'm not sure if I even want to restore this. I've repaired it and definitely made it so it would work. But there's the top cover, and then this timber cover screws back onto it.